start our class, let us do our energizer. So our energizer is called Group Yourself. So if you will win the game, you will receive some prizes from me. So let's start.
Group yourselves into 4.
Game is the group of Renzel Dakyo. So you will get your prize after the class. So now let's begin our discussion. So our topic today is all about problem solving heuristics. So but before that, let us know first our learning outcomes. Learning outcomes. At the end of the lesson, the students must have first, define problem solving and heuristic through interactive discussion. Second, summarize the importance in looking the pattern and the difference conjectures and heuristic. Third, illustrated a diagram that relates problem solving heuristic. So let's proceed in our formal discussion, but before that, I have a question for you, class. So for you, what is problem solving and heuristics? That's right. Problem solving is a mental process that involves discovering, analyzing, and solving problems. The ultimate goal of problem solving is to overcome obstacles and find a solution that best resolves the issue. So, second is heuristic. So when we say heuristic, the term heuristics from the Greek means serving to find out or discover. In the context of problem solving, heuristics are experientially derived cognitive rules of thumb that serves as guides in problem solving processes. And now, we tackle about founder of heuristics. So the founder of heuristics is George Pulya. So he is the one of founders in heuristics in the Hungarian mathematician who published a book about the subject in 1945 called How to Solve It. He used 4 principles that form the basis of problem solving. So now let's proceed in search for pattern and formulate conjecture. But we define first about what is pattern and conjecture. So when we say pattern, in mathematics, patterns are a set of numbers arranged in a sequence such that they are related to each other in a specific rule. These rules define a way to calculate or solve problems. So when we say conjecture, the Latin roots of conjecture translate to throw together. We are throwing together many observations into one idea. Conjectures are unproven claims. Once someone proves a conjecture, it is called a theorem. Theorem, a general proposition, not self-evident, but proved by a chain of reasoning. A truth established by means of accepted truths. So now, let us know about the types of conjectures. So there are four types of conjectures, which are the understanding conjectures, evaluating conjectures, testing conjectures, and writing conjectures. First is the understanding conjectures. So when we say understanding conjectures, we seek to understand a conjecture at three levels. So first, we want to determine its meaning. Second, we want to identify reasons for why we might believe the claim to be true. Third, we want to understand how it fits within some larger set of ideas. The initial steps we take when exploring a conjecture are similar to those used to understand a definition. So first, read the statement. So you need to read the statement so that you catch up and understand the statement. So second, identify each of the conditions of the conjecture. Third, generate examples and non-examples. Fourth, look for counter-examples. And lastly, fifth is compare. Second is evaluating conjectures. In these conjectures, we know what are the possible characteristics of a conjecture and what makes one conjecture more interesting than others. Students should explicitly answer each of the following questions when they seek to evaluate a conjecture. So, we need to questions the students. So first, we need to ask, does the conjecture appear to be true or false? Is it obvious or subtle? Third, is it easy or difficult to understand? Fourth, is the conjecture general? Fifth, is it specific enough? And lastly, sixth is, do you like the conjecture or do you find it appealing? Third is the testing conjectures. It is the first question that we face in evaluating a conjecture in gauging whether it is true or not. While confirming examples may help to provide insight into why a conjecture is true, we must also actively search for counter-examples. And lastly, fourth is the writing conjectures. When we say writing conjectures, for students, there is often a wide gulf between the ideas with which they can grapple and their ability to write a clear statement of their thinking. They need to learn the mathematical vocabulary and formal structures that make writing a logical claim easier. So now we proceed in the examples. So now we need to look for pattern. So first example, Carmen uses the letters in her name to form the pattern below. So the word is Carmen Carmenca. So what will be the 405 letter in the pattern? The solution goes this. So first, we need to understand. So what is fine is the 405 letter in the pattern. So what is known? The pattern is formed by the letters Carmen. So the pattern starts repeating itself from the seventh letter. So second, choose. So we need to look for patterns. So third, solve. So Carmen is the repeating block of letters. There are 6 letters in each block. So 405 divided by 6 equals 67. Remainder 3. So there are 67 such blocks. The remainder of 3 means we have to count 3 more letters to get to the 405 letter. So the word is Carmen. So we need to count 1 to 3. So the letter R is the pattern of 405 letter. So fourth is check. So we need to check if our answer is correct or not. So, how many letters are there in 67 blocks of Carmen? So, we have 67 times 6 equals 402. So, did I count to the 405 letter? So, we have 402 plus 3 equals 405. So, the answer is correct. And now, we already done about searching for pattern and formulate conjectures. So now, let's proceed and make a diagram. This is the example. So draw a diagram. So second example is there were 158 children in a movie theater. There were 267 more adults than children in the theater. So 236 of the adults were men. How many women were there in the theater? The solution goes this. So first, remember we need to understand. So what to find is the number of women in the theater. So what is known? There were 158 children. There were 267 more adults than children. There were 236 men. So second is we need to choose. So we need to draw a diagram or model. Third is solve. So this is the diagram. So there were 158 children and there were 267 more adults than children. So we have 158 plus 267 equals 425. So there were 425 adults in theater. So 425 minus 236 equals 189. So there were 189 women in the theater. So fourth is we need to check if our answer is correct or not. So how many adults were there? So we have 236 plus 189 equals 425. So were there 267 more adults than children? So we have 425 minus 158 equals 267. So the answer is correct. That's the end of my discussion. And now, let's have an activity. So you need to solve the following problems. So first problem, Ben cuts a cake into 5 equal pieces. He wants to eat some of the pieces of cake so that the fraction of cake he eats is smaller than the fraction of the cake left. What is the greatest possible fraction of the cake that Ben can eat? So second problem is Tommy has 3 boxes of apple. Box A is 550 grams heavier than box B and 770 grams heavier than box C. The average mass of the 3 boxes is 2,150 grams. So find the average mass of box B and box C. So give your answer in kilograms and grams. After answering your activity, you need to present your output in front of the class. And after that, I will give you an assignment. And your assignment goes this. You need to formulate your own problem and answer it through looking your own pattern in diagram. Then after that, you need to explain your work on how you come up with that problem. So that's the end of my discussion. I hope that you learned something about my topics. So thank you for listening, guys.